Okay, so we're looking at mixed exercise 5 from the first year core textbook, and we're looking at question 17. Okay, so we have got, let's get my screen up. Okay, right, so okay, so we have got the line y equals 3x, so that is going to be a line with a gradient of 3 going through the origin. Okay, and xy is any point on that line. So rather than call it just xy, I could call it x and 3x. Yep, so that's just rather than putting y as the coordinate there, I'm putting 3x because I know that's how I would work out y. Okay, so, and then I've got the coordinate -1, 5. It doesn't need to be an accurate sketch, but -1, 5 can be about there somewhere. Obviously, very much not drawn to scale. And I want an equation in terms of x for the distance between those two lines. So let's call that distance d. Okay, so find the distance between two lines. It's basically using Pythagoras. So it's your, so d is going to be the square root of x minus x1 minus x2. So that's going to be x minus -1. So x plus 1 all squared. And then the difference between your two y coordinates. So 3x minus 5. So just to clarify, the reason that's x plus 1 is because it's x minus -1. You can do it the other way around. So if you had -1 minus x in your first brackets and 5 minus 3x in your second brackets, that'd be absolutely fine. Because we're squaring, it wouldn't matter if you did this take away this and then this take away this, that would work as well. Okay, and that'll do. It doesn't mention simplifying, just an equation in terms of x. So that is in terms of x. So I'm not going to make life more complicated, and I'm just going to leave that as it is. Okay, so find the coordinates of the 2 points B and C, which are on 3x, and they are both the distance of root 74 from -1, 5. Okay, so this is carrying on from part B. So basically, they're just saying they want that distance to equal root 74. So let's write, so root 74. So this is where I'm going to need to simplify and solve this equation. Okay, so first thing to do, I think, is just lose the square root, so square each side. And then, in fact, at the same time, I'll also square out those brackets. So this set of brackets will become x squared plus 2x plus 1. And this set of brackets will be 9x squared minus 30x plus 25. So that's the quadratic. So let's make it all equal to 0. Let's flip it a bit. So that's the x squared plus the 9x squared. The 2x minus the 30x is 28x. So that's that and that. And then I've got 25 plus 1. And I'm going to minus the 74. So that will give me minus 48. Okay. It did say coordinates of the 2 points B and C. So that's good. I've ended up with a quadratic because I'm expecting 2 solutions. You can just put that straight into your calculator. I'm going to hazard a guess that it probably factorizes. You would be absolutely fine just to put this into your calculator. What can I get? 6 and 4, 4 and 6 I think is going to work. So if I put 4 there and 6 there, I can get minus 20x plus 6x. So x is minus 6 over 5, or x is 4, and then I need the coordinates. So they were on the line y equals 3x. So if x is minus 6 over 5, y is 3 times that. And if x is 4, y is 3 times that. Okay, and the reason, if we go back to our diagram, the reason there's two possible values, well, let's say that that red line has a length of root 74. There'll be another coordinate down there that also has the same length d. So that's geometrically how we can get two solutions. Let's just double check those answers before we carry on, make sure I haven't done anything daft. Yeah, we've got the same as them, that's always good. Okay, so for C, find the equation of, so looking at part C, find the equation of the line L1 that's perpendicular to 3x. And okay, so actually this is sort of independent of the previous part. So you could do this even if you've got a bit stuck. So basically, if it's see the question. So if it's perpendicular to 3x, I'm writing y. If it's perpendicular to 3x, it's going to have a gradient of minus a third, and it goes through minus 1, 5. So I'm going to use y minus my y coordinate is my gradient times x minus my x coordinate. So that's x minus minus 1. Doesn't ask for it in a particular form. So I think the easiest thing to do is to multiply up by the 3. So make the left-hand side 3y minus 15, multiply through by the minus 1, and then make the whole thing equal to 0. But any equivalent version of that would be fine. Find the coordinate of the point of intersection between line 1, so that's the line we've just found, and y equals 3x. Okay, so this is my line 1. So again, lots of different ways we could tackle this. So I basically want to find where those two lines intersect. So I'm going to do it by substituting that into that. So 3y becomes 3 times 3x, and I end up with an equation just in x. Oops, I forgot to write the x. So x is 14 over 10, or 7 over 5, and I imagine it said find the coordinates. Yeah, it said find the coordinates. So I've got either equation I could use, but this is the easier one. So if x is 7 over 5, y is 3 times that, so 21 over 5. Or I could have used that equation as well, or I could check it does work in that equation just to make sure. Made any arithmetical slips. Okay, and then find the area of triangle ABC. Okay, so definitely want a sketch for this. So B and C were our two answers here, I think. So that was B and C. So it was 412. I forgot what they were. Let's write them down. So it was 412. It was minus 6 over 5 and minus 18 over 5. And what was A? Was A the original point? Yeah, and A was minus 1, 5. Okay, so I'll get it roughly, a rough sketch drawn to scale. So minus 1, 5 can be about there. 412 can be about there. And minus 16 minus 18 over 5, so that's minus 1.2. So that can be about there, and then 18 over 5 can be about there. Oh, which you can't see. Okay, this is just so I can roughly see what's going on, and I want. Well, actually, I feel I've missed something quite important, haven't I? Which is, oh, hang on. So B and C are both on the line 3x, and line 1 is perpendicular. Oh no, maybe I'm fine. Right. Okay, so I want the area of that triangle there. Okay, so this isn't worth that many marks, I don't think, is it? So this is only worth 2 marks, so there definitely has to be some kind of trick that I can use. Well, what do I know? Well, I know, so which of these is y equals 3x? So B and C were both on the line y equals 3x. So that's the line y equals 3x. Oh yeah, so basically, and I already knew, so the original part of the question, I was working out the distance of this from the line y equals 3x. So I know it does not look like it on my dodgy sketch, but that's actually an isosceles triangle where both of those are root 74. So, and what else have I found? And I think we said that yep, right. So the other thing we worked out where the line, let's just get a different colour on the go. So we worked out where the line that is perpendicular to y equals 3x and goes through minus 1, 5, crosses y equals 3x. So this pink line is that line there. And in part D, we worked out that they intersect at, so that coordinate there is that answer there. So 7/5, 21/5, right. So perpendicular triangle. I want to do half base times height. So all I really need to do, I might even have missed some other shortcut actually, because even this seems a bit much for 2 marks, but it certainly could be correct. So basically, if I can get that length there, which I can, that's the base of my triangle. So let's get that. So that length there is just the distance between those 2 points. So I'll call that B for base. So the base of my triangle is the square root of 14 minus 6/5 all squared, and then 12 minus 18/5 all squared. So let's plug that into my calculator. So what's that going to be? 14 plus 5 squared plus 12 plus 18/5 all squared. Square rooted. Okay, so I might need to double check some of my arithmetic, but I'm getting that as let's go back and do it as a surd. So I'm getting that back as the square root of 2372 over 5. Won't 100% guarantee that's correct, but we'll check it in a second. And then I just need that length there for the height. So the height of my triangle is going to be square root of so I'm going to do 7/5 minus 1 all squared plus 21/5 minus 5 all squared. Okay, so 7/5 plus 1 all squared plus. So I'm getting that as the square root of 32 over 5, so that's the square root of all of that. So if I don't anything silly, the area of that triangle is going to be half times the base times the height. So fingers crossed. 2, 5. So sorry, I'm just putting that in my calculator. It's coming out as a decimal, so I'm just going to change it to a decimal. I don't think I'll read the question again, but I don't think it mentioned the exact form. No, it just said find the area. Oh, I've not got the right area. Okay, so I think, I'm just going to quickly check that, because I think that might just be me entering into the calculator a bit too quickly, because we did get, we got all the same coordinates. Okay, so let me just double check I've entered that in correctly. So do that. So it was 4, 12, and 25. Was that? Yeah. Okay, so I'm just going to check that on my calculator again. So I'm getting that. Okay, right, I'll have to have a think about that, because I'm still getting 27.6. Okay, right, yeah, realise what I've done. You probably spotted before me. I have, after careful consideration, I for some reason decided to change a 4 to a 14. Okay, so if you don't do that, you will end up with, so obviously that meant that was wrong, so you should end up, if you use 4 instead of 14 there, you will end up with the correct answer of 20.8. Okay, glad I don't have to do the whole video again.